So we want to look at the solution to the question on the board. So I gave you 2 minutes to try, and I know by now you've been able to get your answers. Now let's see if your answers are correct. Now the question says, in the diagram below, ABC are points through the circle center O, and angle CAB is 58 degrees. So I've told you the angle given, you go and check and see which angle has been given. Is it angle at the center? Is it angle at the circumference? And which chord is subtending that angle? You ask yourself all those questions before you answer the question. So I'll go and check the CAB given. This is my angle CAB, 58. So I'll realize that that 58 degrees is angle subtended at the circumference. It's angle at A, 58. I will look at the chord that is subtending that angle 58 degrees. So that chord must have a connection with the two lines that creates the angle 58. So the two lines that creates the angle is this line and this line. So I'll trace down here, and I realize that this line has a connection with point C. I'll trace this one also here, and I also realize that this line also has a connection with point B. So it means that this chord CB, why is CB a chord? Because CB is joining 2 points. It joins the point C to the point B. So CB is a chord. So chord CB is subtending angle A at the circumference, or is subtending 58 degrees at the circumference. Now, if I look at angle O here, that is the angle at the center, this angle. Now, let's look at the two lines which creates the angle O and its connection with the chord CB. Now, if you look at the angle O, these two lines, this line, and then this, creates the angle at O. Now, you realize that this line has a connection with the point C, and this line also has a connection with the point B. So this chord CB here is holding angle O at the center. So chord CB is holding O at the center. The same chord CB is holding A at the circumference. So it means there is a connection between the angle at the center here and the angle at the circumference. Or in other words, there is a relationship. And the relationship is that the one at the center is twice the one at the circumference. Or the one at the center is 2 times the one at the circumference. So you put down that connection or relation, and that will help you to solve the question. So one chord CB is holding one angle at the center, and the same chord is holding one angle at the circumference. So I will connect the two angles. So in my solution, theorem 1 is telling me that the angle at the center is twice the angle at the circumference. So I know angle at the center is angle O. So either I say BOC or COB. So angle BOC is, we use equal to S, twice angle at the circumference. Angle at the circumference is angle BAC or CAB. So it's twice angle CAB. I'll check from the diagram these two angles. I'll look at the one that has been given to me. If you check from the diagram, BOC is not given. This is BOC. Nothing was given. But I realize that CAB has been given to you. CAB, that is 58. So we know this angle here. So this implies angle BOC is equal to 2 times 58. This will give you 116 degrees. 116 degrees. So this angle here is 116. And that was the first thing they asked us to find. That is the I part of the question. Find BOC. So this one, we've been able to find the angle BOC. That is 116 degrees. Now the next question says that find angle BCO. So just follow the point B, point C, point O. The angle is at C. So this is point B, C, and then O. So if I join the point B to the point C and then C to O, it is this angle over here, angle at C, this angle. So I want to determine the size of this angle. Now you realize that this angle is not given, and then this angle is also not given. So it is going to be difficult for us, because if I look at this triangle here, I have BOC. Now for any triangle, if you know two of the interior angles, you can find the third side. But in this diagram, you realize that I have only the angle here. The one here is not given, and the one here is also not given. They want me to find the one here. But you realize from the beginning of the lessons, I told you that because this line OC here is a radius, and this line also is another radius, it means that this length and this length are the same, or they are equal. So this length here is equal to this length. So if this length and this length are the same, then it means that the base angles are also going to be the same. So if this angle here, if I call this angle X, then what it means is that this angle is also going to be X. So that now I know all the three angles now. This is X, this is X, this is 116. I will solve for X from this diagram, and I'm going to get the angle at C, or BCO, as the question required. BCO. So if I'm able to get X, I'll get the angle at C. How do I get X? Now I know all the angles here. So sum of angles in a triangle should give us 180 degrees. So 116 plus X is equal to 180. Then I'm going to solve for the angle at C. Okay, so let's look at how to go through the steps to get that. So first, we were able to get the angle here because the length here and the length here were the same. So because the two lengths were equal, it made the triangle isosceles. So I'll have to state that in my solution. So I'll say that this length and this length are equal. So line OC is equal to line OB. And that is what I've done here for you, this line and this line, so that you see that they are equal. Now, if these two lengths are equal, then it means that this triangle becomes an isosceles triangle, because any triangle in which two lengths are equal is isosceles. So if line OC is equal to line OB, then it implies triangle CBO is isosceles. So if it is an isosceles triangle, then it means that the base angles are equal. So I'll say this implies this implies angle BCO equals angle CBO, and is equal to X. So you realize we are using X for those angles. So that is why I say this angle equals that and is equal to X. So these two angles are the same, XX. From triangle BCO, so now I want to sum the angles in the triangle to get my answer. So from triangle BCO, 116 degrees plus X is equal to 180 degrees. Take this 116 to this side. So this implies X plus X is equal to 180 minus 116. Two X will be equal to 64. Then because I want to find X, I'll divide this side by 2 and divide this by 2. This will cancel that. 2 will go into 64, 32. It implies x is equal to 32 degrees. But please note that the question is not looking for x. You were asked to find BCO. We are saying BCO is equal to what? X. So when you find x, you will need to find BCO. Therefore, angle BCO is equal to x and is equal to 32 degrees. Or you can just remove the x there and just straight away say, therefore, angle BCO equals 32 degrees. It is also accepted. They will mark that for you. It is also accepted. We'll look at our final question for today. Look at our final question for today. So this is our last question for today. The next class, we are going to continue by looking at theorem 2. After I'm done with this, I'm going to take all the past questions from 1978, and we are going to solve it one after the other till we get to 2019. So that will be all for theorem 1 for now. There are a lot of questions that I can ask, but I want us to go to the theorem 2. That will be in our next lessons. We'll look at theorem 2 and the other aspects. And when we are done, we'll put all the theorems together and see how best we can be able to go through. God richly bless you for your time. Please go through these questions and make sure you do it all by yourself. Practice is what perfects you. If you want to become a good mathematician, you want to become good at mathematics, it is through practice. So I want to leave you with this one. In our next class, I'll provide you with the solutions to them. But please try and solve it all by yourself. And please remember that Rome wasn't built in a day. So it takes time. Take it one after the other. Social, maths, science, bit by bit. This corona has given us time for us to sit and do more studies. So please, let's use our time judiciously. God richly bless you once again. On that note, ladies and gentlemen, that brings us to the end of the entire caboodle. I'll see you. God richly bless you. Bye-bye.